Okay, let's talk about moments. So we have talked about moments before. You might not remember it, but it was a while ago, back when we were doing our simple machines. So we have done this before. Okay, so a moment of a force is a measure of the tendency of the forces to rotate. So rotate is pretty important here. The body upon which it acts. So what you'll see happening is that this force will either rotate in that direction, or it might push the other way and rotate the other direction. So a force is being applied to something and it's causing it to rotate. So the moment is that force that's causing the rotation. So we're going to talk about some terminology here, and on your note sheet you will see this picture, and as I go through the different parts of the picture, please label it. So the first thing is the force. The force is going to be the F. So the force might push down over here. There might be a force somewhere in the middle of the lever. There might be a beam of some sort or a truss of some sort, and you might see a force push down there. So we have seen those things before when we were talking about the different levers. The next thing is the pivot. The force will cause a reaction to happen either in a clockwise or a counterclockwise motion, and that will come up later, but it does go around a pivot point. And the last important is the distance. So the distance goes from the pivot point to the location of the force. And it is important to note that the distance must be perpendicular to the force. So we have our force, we have our distance, it is perpendicular. Our formula is moment equals distance times force. We have used this formula before. So M is going to be your moment, D will be your distance, and F will be your force. And remember that it is a perpendicular distance to the force. So if you're looking at your formula sheet, you'll probably see like a D perpendicular or something along those lines. When we are solving for force, you are multiplying the force and the distance. So if you're talking about English customary units, you will be talking about pounds and feet, so it becomes a pound-foot. When you're talking about SI, it will be newtons and meters, so it becomes Newton meters. Those two units cannot just simplify to something else, they are that. So I said that rotation matters. So counterclockwise is going to become a positive number, and clockwise is negative. So if the direction of the pivot, so we saw earlier that my pivot point was here and I had this force pushing down over here, that becomes a clockwise motion around this pivot point, therefore it is negative. If I have the force pushing down over here and that force is causing this to go counterclockwise, opposite of a clock, then it is a positive force. So the force itself, so this one counterclockwise is positive, clockwise is negative. That will be really important when we're solving for our trusses. So let's try one of these things. We have a force of 20 pounds, and that is important, so I'm going to highlight that. And a distance of 9 inches. But if you remember my units, I had feet and I had pounds, so I need to change that first. So then my distance becomes 0.75 feet, so now I can actually do these the right way. So the first step is I need to figure out, is my force positive or is my force negative? So if it is pushing down in a clockwise direction, we said that that was a negative force. So the moment equals the force times the distance. Moment equals a negative 20 pounds times 0.75 feet. So my moment is negative 15 foot-pounds, or 15 foot-pounds clockwise.
All right, so we're going to try just a little bit longer wrench. If you notice over here, we're still moving in our clockwise motion around our pivot, so it is going to be a negative force. My formula is moment equals the force times the distance. And if I look at my force, it's in pounds, and my distance is now in feet, so I don't have to convert anything, so that's pretty awesome. So I'm going to do moment equals 20 times 1. That 20 is negative. My moment equals negative 20 foot-pounds. So now I have a different type of wrench. This is an L-shaped wrench. My force is still being applied in a clockwise position, so it's still a negative force. But now I have two distances. I have a 1 foot distance and a 3-inch distance. So to decide which distance I need to use, I have to look at the force being applied. If the force is being applied here in the horizontal position, you have to remember that the distance needs to be perpendicular. So perpendicular means I need it to run vertical. So I'm going to use this 3-inch. But again, that's in inches, so I'm going to convert. 3 inches into feet would be a 1/4 foot. So now I can solve. So the moment equals the force times the distance. My force is negative 20. My distance is that 1/4, 0.25. So my moment equals negative 5 foot-pounds. Let's take a look at a Z-shaped wrench. So again, I've got a force pushing down. It is clockwise, so it is negative. And I have to figure out what my distance is that is perpendicular to that. So since the force is pushing downward, the distance is going to be running in the horizontal, but it has to be the entire thing. So my total distance here, the distance perpendicular, is 18 inches. But I need that to be in feet. That is 1.5 feet. Now that I've got that, I can go ahead and solve. So I've got my moment equals the force times the distance. Moment equals negative 20 times 1.5. And that equals out to be negative 30 foot-pounds. All right, just 2 more examples, guys. Hang with me. This time we're going to be dealing with a wheel and axle. As you can see, my force is pushing downward. So if I think about me spinning this wheel, it's going to be spinning in this direction. So now we're going counterclockwise. Counterclockwise, we said, is a positive force. So my force is now positive, 100 newtons. Now my distance is the radius here because it's around the pivot point. So if you think about this right here, there's my pivot point out to here. That is going to be perpendicular to that force. So I need that distance, but I need that distance not in centimeters, because if you remembered that table that we had at the beginning, I was going to be finding either foot-pounds or Newton meters. So I need centimeters to be converted into meters. So we have 50 centimeters. That into meters is 0.5 meters. So now I've got what I need in order to solve. So same thing, moment equals the force times the distance. There is no change. I have a force, I have a distance. It's still rotating around a pivot. I know it looks circular, but it is just still a lever in this case. So moment equals, my force is 100. It is positive. My distance is 0.5, so my moment equals 50 Newton meters. All right, last one, and probably about the trickiest one that you'll see. We still have this wheel and axle, so I've still got a pivot point happening here. But now instead of my force being straight down, my force is coming at this angle right here. Which is going to be 50 degrees from the horizontal. So I know that the force on the vector is 100 newtons. Now we've talked a lot about vectors here recently, and how they are made up of an x and a y. So we need our force to be perpendicular to the distance that's given. So here's my distance again. It's still that 50 centimeters, and we said that that equals 0.5 meters. So we want a force that is perpendicular to that. So it can't be this right here. It has to be this F of y, the force of the y leg of my vector there. So in order to solve for that, just like we have been doing, we're going to use our sine. So we've got the sine of the angle, so in this case the sine of 50 degrees, because that happens to be this right here, equals, and it's going to be my opposite, so the f of y, so I'm just going to call it y, it's hard to see, sorry, y over my hypotenuse. My hypotenuse is 100 newtons. So I can now multiply both sides by 100. So y equals 100 times the sine of 50. And that force in the y then becomes approximately 76.6 newtons. So this right here is that force pushing down perpendicular to my distance. So now I can solve the moment equals a force times the distance. Now it's rotating in a counterclockwise position. We say that's what? Positive. So it's going to be a positive force of 76.6 times my distance. Remember, we're using the meters. So 0.5. So my final moment is going to be 38 Newton meters. Now we will have more stuff later on, and then you'll see how it's going to start apply to beams, which is similar to what's going on with trusses. But for now, we're done. Congratulations, you made it.